Revision 2 on statics and solid geometry. Answer all of the following questions. First question, choose the correct answer from those given. 1. Two forces of magnitudes 3F and 2F, and the magnitude of their resultant is 5F. Then the measure of the angle enclosed between the two forces equals 0, 60, 20 degrees, or 180 degrees. Note that the resultant is 5F. It is the sum of the two forces, as 3F plus 2F equals 5F. So we have the maximum value of the resultant, which is 5F. So the angle equals 0, but we can prove it in steps. R equals square root of F1 square plus F2 square plus 2F1 F2 cosine alpha. It is the main rule to get or to calculate the resultant of two forces. And by substituting, we have R equals 5F and F1 is 3F, so F1 power 2 is 9F square, F2 square is 4F square, plus 2 multiply 3F multiply 2F, which equals 12F power 2 cosine alpha. And by squaring the two sides, what we get? 5F power 2 is 20F square, which equal 9F square plus 4F square plus 12F2 square cosine alpha. And by simplifying the two sides, we have 12F square equals 12F square cosine alpha. Because 9F square plus 4F square is 13F square, and 25F square minus 13F square equals 12F square. So cosine alpha equals 12F square divide 12F square, which equal 1. Then cosine alpha equals 1. Then alpha equals shift to cosine 1, which equal 0. So the angle enclosed between the two forces equals 0. And the answer is A. To the point that lies on the circle x minus 2 all square plus y square equal 13. One of these 4 points. So we substitute and try every one. When we substitute x equal 4 and y equals 3, what we get? When x and y equals 4 and 3, we get the left hand side equals 4 minus 2 all square plus 3 square, which equal 13. Substituting x equals 4, so we have 4 minus 2. And substituting y equals 3, we have 3 power 2. 4 minus 2 all square, it is 4, because 4 minus 2 is 2, 2 square is 4, plus 9 equals 13. And this is equal the right hand side. So the answer will be D. All of the following cases form a plane except a straight line and a point do not belong to it. B. Two different parallel straight lines. C. Two intersected straight lines. In these 3 cases, we can form a plane. But the two skew straight lines cannot form a plane. Two skew straight lines cannot form a plane. So the answer will be D. Because the question about the exception here. So all of the following cases form a plane except two skew straight lines. For two forces of magnitudes 5 and 3 Newton, and the measure of the angle enclosed between them is 60. We have alpha equals 60. Then the magnitude of their resultant R equals. Now, applying the rule, we have R equals square root of f1 square plus f2 square plus 2 f1 f2 cosine alpha, and we substitute by the values of f1 and f2. So we have f1 square is 25, f2 square is 9, plus 2 multiply f1 f2. 2 multiply 5 multiply 3 equals 30 cosine 60. But cosine 60 equals half. So we have 15 here, plus 9 plus 25 is 34. And by squaring the two sides, we get r power 2 equals 49. So r equals square root of 49 equals 7. And the solution will be B. Here. Second question. If three coplanar forces F1 equals 5I plus 3J, F2 equals AI plus 6J, F3 equals negative 14I plus BJ. Act on a point, act at a point, and their resultant R equals 10 root 2 and 3 over 4 pi. Find the values of A and B. We have R equals 10 root 2 and 3 over 4 pi. 3 over 4 pi equals 135. It is the measure of the angle between the resultant R of magnitude 10 root 2 and the positive direction of x-axis. And we have R equals the sum of the three forces. So we will use these two informations. Solution. We have R equals, by adding F1 plus F2 plus F3, what we get? F plus A plus negative 14 in the direction of I, plus 3 plus 6 plus B in the direction of J, such that I and J are the fundamental unit vectors in the direction of X and direction of Y. And we simplify. We have 5 minus 14 is negative 9. So we have A minus 9 I, and 3 plus 6 is 9 plus B in the direction of J. And this is 1. So we have R in the form, in this form, in terms of the two unit vectors I and J. And we'll use the second information. We can write R equals 10 root 2 cosine 135 plus 10 root 2 sine 135 in the direction of J. And we simplify this. We have R equals negative 10I plus 10J. multiplying 10 root 2 by cosine 135, we got negative 10, and 10 root 2 sine 135 equals 10. From 1 and 2, and by comparing the coefficient of I and J here, we have A minus 9 equals negative 10, and 9 plus B equals 10. And we complete from 1 and 2, we get A minus 9 equals negative 10. It means A equals negative 1. And 9 plus B equals 10, so B equals 1. B equals 10 minus 9, which equal 1. Question 3. A body of weight 300 gram weight is placed on a smooth plane inclined to the horizontal with an angle whose tangent equals 1 over root 3. Here we have this plane, the plane here, and the body inclined to the horizontal by an angle of measure theta, where tan theta equals 1 over root 3. The body is prevented from sliding by a force from form with the line of the greatest slope an angle of measure 30. Here is the force which prevent the body from sliding down, and this force inclined to the plane with an angle of measure 30 according to the given. Upward, this force acts upward here. Find the magnitude of the force F here and the reaction of the plane R. So the required is to calculate F and R. We have many ways to calculate F and R to solve this problem, and we'll solve it by factorization. We factorize F into two perpendicular directions, F cosine 30 and F sine 30. Note that the line of action of R is perpendicular to the plane because it is a smooth plane. And we factorize 300 gram into two directions, into two perpendicular directions, 300 cosine theta and 300 sine theta. So now we have 4 directions, and the body is in equilibrium. So first to calculate theta, we have tan theta equals 1 over root 3, so theta equals 30. Theta equals 10 minus 1 over root 3, so theta equals 30. Now we know this inclination angle, and we need it to substitute in sine theta and cosine theta. We have 300 sine 30 equals F cosine 30. Here in the direction of the plane, don't forget that the body in equilibrium, so F cosine 30 equals the 300 sine theta, sine 30 also. From this equation, F equals 300 sine 30 divide cosine 30, which equal 300 tan 30, as sine 30 divide cosine 30 equals tan 30. By calculating right hand side, 300 tan 30, it is equal 100 root 3 gram weight. And this is the first required here, is to find the force. So F equals 100 root 3 gram weight. Now R plus f sine 30 equals 300 cosine 30. Again, r plus f sine 30 equals 300 cosine 30. Then we write it and we can calculate it substituting f equals 100 root 3. So 300 cosine 30 minus 100 root 3 sine 30 equals 100 root 3 gram width. Then now we have the magnitude of f and the magnitude of r, and you can solve this problem here using Lami's rule. Question 4. Find the general form for the equation of a circle whose center is 2 and negative 1 and the length of its radius is 3. The required here is to find the general form. The equation of the circle is x minus d all square plus y minus h all square equals r square, such that d and h, the ordered pair d and h, is the center of the circle. So by substituting, we have x minus 2 all square plus y plus 1 all square. Substituting h equals negative 1, we have y plus 1 all square equals r square, and r is the radius equals 3 centimeters. So we have 3 square. This is the equation of the circle, but the required is to find the general form. So to get the general form, we expand these two brackets. X minus 2 all square equals x square minus 4x plus 4, y plus 1 all square equals y square plus 2y plus 1, and 3 square equals 9. And we simplify it to get the general form. Then x square plus y square, x square plus y square, we write it, negative 4x plus 2y minus 4 equals 0. 4 plus 1 minus 9 equals negative 4 equals 0, and this is the general form of the equation. Question 5. A uniform rod of length 100 centimeters. Here AC is a uniform rod. Since the rod is uniform, then its weight 150 gram weight acts on its midpoint, denoted by the symbol D. Okay, a uniform rod of length 100 centimeters and weight 150 here acts on the point D, it's the midpoint, is hanged freely by two strings BC and BA, and the other end of the two strings are fixed in one point. This point is B here. If the lengths of the two strings are 80, BA is 80, and 60 centimeters is 60 centimeters. Find the tension in the two strings. The required is to calculate T1 and T2. So we want to solve it using triangle of forces rule. We can draw DE parallel to AB to represent the second tangent T2 like this. So the ray DE intersect BC at a point E. Now we have the three forces T1 and the weight here, and T2 acts on the same cyclic order, and the body on equilibrium. This body AC is in equilibrium, so the triangle DEB is the triangle of forces. The triangle of forces. So the three forces are proportional to the side lengths of the three forces. Now we will calculate the side lengths of the three forces. First, we can calculate BD easily, because BD here, BD is a median in this triangle ABC. And note that BC equals 60 and BA equals 80, and the length of AC equals 100 centimeters. Then triangle ABC is a right angle triangle. Right angle triangle at B. And BD is the median from the right angle, so its length equals half the length of the hypotenuse. Half AC, half 100, so BD equals 50. BD equals 50 centimeters. Also, since D is the midpoint of AC, and DE is parallel to AB, then the length of DE equals half the length of AB. The length of AB equals 80 centimeters, then the length of DE equals 40 centimeters. Again, since DE is parallel to AB, and D is the midpoint of AC, then E also is the midpoint of BC. So the length of BE equals 30 centimeters. Now we know the three sides, the lengths of the three sides of triangle DEB. Now we can solve it using the triangle of forces rule. From the geometry of the figure, we can deduce that BD equals 50 centimeters, BD equals 50 centimeters, BE equals 30, BE equals 30, and DE equals 40 centimeters, and T1 and T2 and the weight W are in the same cyclic order. Same cyclic order. And the body, the three forces in equilibrium. Then the triangle BDE is the triangle of forces, and we write the proportional as triangle DEB is the triangle of forces. Then T1 over 30, T1 over the length of BE equals 30, and T2 over 40, here T2 over the length of DE equal which equal 40, equals 150. It is the weight, the force weight over the length of BD. What is the length of BD? It is 50. And now it is easy to calculate T1 and T2 using cross multiplication. Then T1 equals 90 gram weight, and T2 equals 120. T1 equals 150 multiply 30 divide 50 equals 90. T2 equals 150 multiply 40 over 50, which equal 120 gram weight. Question 6. A regular quadrilateral pyramid The length of its base is 20 centimeters and its height is 10 root 3 centimeters. Find the lateral surface area and the volume of the pyramid. We have quadrilateral pyramid, which means that the base in the form of a square and the four sides are equal. Each equals 20 centimeters and its height equals 10 root 3, and the required is to calculate its lateral surface area and the volume of it. So in the solution we start with writing the lateral area of the pyramid. The lateral area of the pyramid equals half base parameter by its slant height. It's easy to calculate the base parameter. It's 4 multiplied 20. And we want to calculate its slant height. Slant height, this black line segment. What is the length of its slant height? We know that this height equals 10 root 3 and the length of this side equals half 20 equals 10. So slant height as a hypotenuse, because it is opposite an angle of measure 90, equals square root of 10 root 3 all square plus 10 square, which equal 20. So the length of slant height equals 20 centimeters. And now we calculate from this triangle, we calculate its lateral area of the pyramid, which equals half multiply 4 by 20. It is the parameter of the base. Multiply 20, which equal 800 centimeter square. And the volume of the pyramid equals 1/3 base by height. Area of the base by height. The area of the base equals 20 multiplied 20. And its height equals 10 root 3. So the result will be 4000 root 3 over 3 centimeter power 3. ABCDEF is a uniform hexagon. The forces of magnitudes 8 and 6 root 3 and 5 and 4 root 3 Newton acts on the rays in the direction of these rays AB and AC, AD and AE respectively. This is the hexagon ABCDEF. And the first force 8 acts on AB in the direction of the ray AB. Here is 8. And the 6 root 3 acts on AC. And the 5 acts on AD. 5 acts on AD. And the 4 root 3 acts on the direction of the ray AE according to the given. Find the magnitude and the direction of their resultant. The resultant of these four forces. You have to know that the angle between AC and AB equals 30 degrees. Also the measure of the angle between AD and AC equals 30. Here is 30, here is 30. As the measure of the vertex angle of the hexagon equals 120. And these four angles are equal in measure and each equal 30. So we will factorize 6 root 3 into two perpendicular directions. The direction of AB and the direction of AE. The component in the direction of AB is 6 root 3 cosine 30. And the component on the direction of AE equals 6 root 3 sine 30. It is the same angle. Okay, and we'll factorize the force F into two perpendicular directions, the same directions. It will be 5 cosine 60 and 5 here in this direction, 5 sine 60. We know that when you factorize 4 root 3, it will be 4 root 3 cosine 90, because the measure of the angle between AE and AB equals 90 degrees. 30 plus 30 plus 30 equals 90. The component of the force 4 root 3 in the direction of AE is 4 root 3 sine 90. Now, what is the angle between the line of action of the force 8 and the AB? It is equal 0. So the two components are 8 cosine 0 and 8 sine 0 here, and we write it. So x equals 8 cosine 0 and the cosine 0 equals 1, so we write 8. It is 8 multiply 1 equals 8, plus 6 root 3 cosine 30 plus 5 cosine 60 plus 4 root 3 cosine 90, which equal 39 over 2. And y equals 8 sine 0 plus 6 root 3 sine 30 plus 5 sine 60 plus 4 root 3 sine 90, which equal 19 root 3 over 2. Now r equals square root of x square plus y square, square root of 39 over 2 all square plus 19 root 3 over 2 all square, which equal root 651. And tan theta equals tan minus 1 y over x, the component y over the component x. What is the value of component y? It is 19 root 3 over 2. What is the value of the component x? It is 39 over 2. So calculating it using your calculator, you will get 40 degrees, 9 minutes, 30 seconds approximately. So now we know the magnitude of the resultant. It is root 651, and its direction. You can say that the resultant are inclined to the horizontal, inclined to AB here, with an angle of measure 40 degrees, 9 minutes and 30 seconds. Now, question 8. A uniform smooth sphere of weight 10 gram weight. You have to learn how to draw such these problems. Again, a uniform smooth sphere of weight 10 gram weight and radius length 30 centimeters is hanged from a point on its surface, the surface of the sphere, by a light string like this. We have here the sphere, smooth sphere. It's hanged from a point on it, from this point on its surface, by this string of length 30 centimeters according to the given. And the other end of the string, here is the string, the other end at the point A, hanged on a smooth vertical wall. Okay, a smooth vertical wall. Find in the case of equilibrium. each of the tension on the string. Here is the string and here is the tension T in this direction. And the reaction of the wall. The reaction of the wall is smooth, so the reaction of the wall will be perpendicular to it. So the required now is to calculate T and R. The weight of the sphere is 10 gram weight and it acts on its center. And since the reaction perpendicular to the wall, it certainly passes through the center from this point. So the line of action of the rule of the string, the line of action of the string passes through the center also. So the length of AC will be 60 centimeters. How we get it? The length of the radius is 30. The length of the string is 30. 30 plus 30 will be 60. In triangle ABC, this triangle ABC, here BC equals half AC. BC equals half AC. So measure of angle BAC equals 30. And the measure of angle ACB equals 60. Here, this angle. Applying Lamb's rule, now we will calculate it using Lamb's rule. Using Lamb's rule. To use Lamb's rule, we must know these angles, the angles between the three forces. This angle, it is ACB. This angle is 60. So the angle between the tension and the weight equals 60 plus 90 equals 150. And the angle between AC and the reaction here, this angle equals 120, because this angle is 60. 60 plus 120 equals 180, two supplementary angles, and this angle equals 90. So you can say 10 divide sine 120 equals R divide sine 150 equals T, the tension, divide sine 90. So 10 over sine 120 equals R over sine 150 equals T over sine 90. And now it's easy to calculate each of the tension and the reaction. So R equals 10 multiply sine 150 over sine 120, which equal 10 root 3 over 3 gram weight. And T equals 10 multiply sine 90 divide sine 120. So the result of the tension equals 20 root 3 over 3 gram weight.